Welcome to the second video concerning EdTPA Task 4. This second video is focused on the assessment commentary prompt 1. And the assessment commentary prompt 1 is looking at the whole class performance. And so in terms of the process of where we are, in the first video, we talked about the development of the assessment. In this video, we are looking at the assessment of student learning, specifically the whole group of analysis where we're looking at patterns of learning. In other words, what do we see across the students in your classroom? What do you observe in their performances? Are a great percentage missing a certain question? Are they missing certain concepts? So you're looking at the whole picture here, and not just one or two individuals. The commentary prompt 1 says this: you need to think about the learning objective. So as you begin your commentary, as you begin your analysis, tell the reader, this is my objective. This is what I'm evaluating. The second piece of your commentary, it says provide a graphic, a chart, or a table. Your best bet, best choice, in my opinion, is to use an Excel spreadsheet that's set up like a grade book. You will see one later in the video. By doing that, you can do an item analysis. You can talk about the performance of individual students. It lets the reader, lets the evaluator see what you are talking about. And then it says, using examples from the summary chart, discuss the patterns of learning across the whole class relative to conceptual understanding, procedural fluency, mathematical reasoning, and problem-solving skills. Those last three terms are the terms that were mentioned in the first video. If you're not sure of what they mean, take a look back. As you go through this video, be sure and have your EdTPA Elementary Education Handbook with you, your rubric progression for rubric 16, you're making good choices for task 4 addendum. Resources specifically, we're looking at commentary prompts 1A, 1B, 1C. And as you think about your commentary, notice the key decisions chart on pages 2 and 3 of your addendum. Automatic 1. This is what you want to do if you want to score an automatic 1 on your EdTPA. First thing, you do not demonstrate that you know your mathematical content. You've got some significant content inaccuracies. So basically, you don't know it demonstrates you don't have an understanding of your mathematics. The second piece is that as they look at student work, the absence of corrections or the corrections you do have shows significant errors. So an automatic 1 says that the evaluator has looked at your work, and that either your work shows significant content problems, or your analysis of your own student work, your corrections show significant content knowledge. That's an automatic 1. But we know that you want a 3. So notice what it says in rubric 16 for a level 3. The candidate identifies what students did right or wrong, right and wrong, related to conceptual understanding and procedural fluency or mathematical reasoning or problem solving. If you look at the rubric progression for a 3, it says it highlights the differences in mathematical performance for the whole class. And here I would say, as you think about your context for learning, if you mention a specific group, if you mention special education students or English language learners, I would include these as you discuss whole class performance. Describe the differences in the performances of those students with other students in your class. And you talk about what students did right and wrong, not just focusing on the negative, focusing on what they did right and wrong, and align your narrative with the analysis that they see. And they give you an example here. So you're looking at your commentary. You look at the questions. You look at the rubric progressions. And then you start looking and say, okay, what do I know? You're going to see a sample assessment. And as you develop your assessment, this would be a good way to begin a framework. The first question you're going to see on the assessment is procedural fluency, addition of fractions with like denominators. Second one is going to be another procedural fluency, addition of fractions with unlike denominators, but using a specified method. Now think about the impact as you're writing your analysis. You have these notes, like notes written like these notes, and they're written down that you can refer to them as you write your paragraphs. For example, question number 4 dealt with conceptual understanding or mathematical reasoning. Estimating the size of the sum of two fractions. Procedural fluency if the students if the students used an algorithm to solve it. Mathematical reasoning if the students were able to think and reason, oh, both of them are close to 1, that means they're going to be greater than 1. Conceptual understanding follows along the same path. What do they see as they look at the two fractions? Do they have to resort to an algorithm, or are they using a different approach? Then as you look further, there's 3 more items, but I have the descriptions here. This way, as I'm looking at the grade book, I can very easily say, oh, this is what that's looking for. And so my grade book would look like this. And so that way, as I look across, for example, as I notice Matt, okay, you got question number 2 right. You got half of question number 3, but he didn't get any others. Whereas if I look down at Helen, she got most of them correct, but she also got half a point on number 3. And if you notice very carefully at number 3, 1, 2, there's 5 students on number 3 who got half a point. That's an observation you want to make. So here you look at your grade book, then you go back to your exam. Okay, number 3, what did it ask them to do? If I wanted to find a fraction equivalent to 3/4, what would I do? Why? Five students only got half credit. The reason why those 5 students only got half credit is this. They said to find an equivalent fraction, I multiplied the numerator and denominator by the same number. So in other words, if I wanted to find an equivalent fraction to 3/4, I'd multiply the numerator by 2, the denominator by 2, that would give me an equivalent fraction. But that's only part of the picture. The reason why you can multiply the numerator and denominator by the same number, in other words, 2 over 2, is the identity element of 1. That 1 times any number will give you that number. The student missed half a point because they did not state that in their answer. So as you look here at the question on the 7 questions on this assessment, if you think back, we've got number 1, number 5 are definitely procedural fluency. Number 2, as you look at it, is procedural fluency because I am saying a specific way to do it. The students don't have an option. In other words, I've taught them a process, I want them to follow it. Number 3 and number 4 are asking the students to use mathematical reasoning. If the students use an algorithm, then they've got procedural fluency. But if they explain it and their explanation makes sense mathematically, you're looking more at conceptual understanding, mathematical reasoning. And then if you look at 6 and 7, 6 and 7 are both asking students to model. So having an intimate understanding of your assessment will help you as you start writing your commentary. You want to think in terms of procedural fluency, conceptual understanding, mathematical reasoning, mathematical problem solving. That's a key part as you look at rubric 16. So the organization of your writing: specific learning objective, your graphic, and then use examples from my summary chart. So my specific learning examples, they've been stated. Here's my graphic. As you look at my graphic, notice what it points out. Notice the red rectangles. This one down here, the lower left, individual item analysis. With that, I can say 80% of my students were correct on number 2. 55% were totally correct on number 3. Number 5, 50%. So I can use those percentages to describe the performance of my students. If you look at the lower right, here's information about my whole class statistics. The average score, the standard deviation, the median, the mode, the range. Now, if you think about using those statistics, make sure you know what they mean. Make sure you understand them, because your evaluator will be able to tell if you're just throwing in the statistics and you don't understand. And then up here in the upper right, you see student total and percent. Their total points, their percent. This is based on an Excel spreadsheet. So we've got our information. We presented that. We've explained a little bit to our readers. Then we think about our commentary analysis. And really what you're doing is blending in multiple pieces of information. First, what is the type of question you were looking at? There you have those terms again. Procedural fluency, conceptual understanding, problem solving, mathematical reasoning. Was it a hybrid? Did the student's choice of answer make it a different type of problem? The second question you want to include for your evaluator: what was the content of the question? In other words, what did the question ask the students to do? Don't just say problem 2, say problem 2, which asked the students to do this. Level of performance. How did the whole class do on the question? Did most of them miss it? Did most of them get it right? What type of errors did you see? And then, if you've identified specific groups in your context for learning, include those in your analysis. Include those. And so that's the basic framework as you think about your analysis. So let's see. These are possible paragraphs. The class average on the exam was 66%. However, the average was influenced by 3 scores that were less than 25%. A better representation of the class performance was the median score of 82%. The upper 50% included 3 perfect papers with 2 additional scores in the 90s. So what I've done with that paragraph is given a general overall view. This type of paragraph you may put before your summary chart, or you could put it as the first paragraph after. But what you're trying to say is, here's the overall picture of how my students did. A second piece, as you look at it, this one is looking at an individual question. When you think about your analysis of your assessment, you can think about it in terms of, okay, I'm going to talk about the whole group. I'm going to talk about an individual question. Or I'm going to talk about pairs of questions. Or you could think in terms of groups of students. So this question right here is looking at one question. 70% answered it correctly, which required them to add 2 fractions with like denominators and demonstrate procedural fluency. So I've said the content, I've said the type, I've said the percentage. And then notice what I said, the 3 students who recorded incorrect answers, I give an analysis of what they did. So those who did it right, did it correctly. The 3 who did it wrong, treated the numerator and denominator of each fraction as individual numbers. That's an analysis. Instead of one question, you may want to describe 2 questions. For example, if on your assessment, whether 2 consecutive questions or just 2 questions in general, focused on the same type of mathematical thinking or mathematical reasoning, what you could do is combine your descriptions into one. You could link the content. And that's what you're seeing here as you look at this paragraph. 2 questions, 3 and 4. Ask the students to describe a process or add 2 fractions without performing an operation to examine the depth of their conceptual understanding, mathematical reasoning. As they were explaining how to find equivalent fractions, 3 students made the connection between multiplication by 1 and multiplying a fraction by another fraction, having a numerator that was equal to the denominator. So that's one statement. That's one element of their performance. Second element, 5 students, though, could not extend the concept beyond procedural fluency and did not state any connections with multiplying by 1. In other words, they could multiply by 2 over 2 or 1 whole, but they didn't know why, they didn't state why they were doing it. My 2 students who are learning disabled were unable to describe how to create an equivalent fraction. And then I described the second part. The companion question asked students to state whether the sum of 4/5 and 5/6 was greater than 1. And I describe how those students did it. But what I've said to my evaluator, what I've said to my reader, I've identified the problem number, I've identified the content of the number, I've identified the type of response I received from my students. So this is an example of how you can integrate those 3 pieces into one paragraph. Here's another example. I'll let you read this one. And this one, you're looking at 3 problems. And they're able to use a model, an algorithm, or mathematical reasoning. But once again, it's the same process. You're integrating it. Instead, doing it very much like a staccato. Instead, you want to weave it like a tapestry to say, here's what's going on. That brings us to the end of this video. The third video in this series will examine how to describe the performance of your 3 focus students. It will be building on the analysis that you've seen in this video. Thank you.